Good afternoon, everyone. In the last lecture, we have started with the WPA wireless security. Okay, we have seen few concept of WPA. That we have started with the temporal key integrity protocol. We have seen what is message integrity code and IV sequence enforcement. Then we have seen today we are going to another part of it. So the next process is a mixing of keys. Okay, so what is the reason that we are mixing the keys? So now suppose this is to provide a type of this is to provide any type of what we can say spoofing or man in the middle attack. Okay, so let's see what is the key mix is, or what is key mixing means. So the key mixing functions that provides, or key mixing function provides, means to generate a intermediate key. It provides means to generate a intermediate key. Just a minute. The intermediate key, which will unique in nature, okay, for each station, okay, and that is generated by the means of station's MAC address. Okay, so that is your physical address, and one more thing it will generate, that is a temporal key. Okay, so this intermediate key has a lifetime equal to the temporal key. Okay, use of this intermediate key. Okay, so this intermediate key has a lifetime to temporal key, and this is used to encrypt packet sequence number. Okay, so the sequence number of packet is now also encrypted. Okay, WEP number in, okay, now here the sequence number is given to the packet, so any intruder will not know at what point currently the transmission is. Okay, whether it is just the beginning of a transmission or whether it is just the end of transmission, that intruder will never into. Okay, so that is also now encrypted, the sequence number, because sequence number is also encrypted, we have just seen, and this sequence number is encrypted by the intermediate key. Encrypting a packet sequence number. Okay, so this intermediate key is used to generate a 128-bit per packet encryption key. Okay, so WEP based concatenation of a per packet key and IV is avoided by masking the portion of IV. Okay, so thus saving the RC4 weak key problem. Okay, so if you remember in WEP, what we used to do while concatenating the per packet key and IV, we are masking some portion of IV. So because of that, weak key were generated, but here it is not possible in the case of WPA. Okay, so if you recall, let's recall what happened in WPA. We saw initialization vector and the shared. These were concatenated. Okay, initialization vector and second one is share key. These were concatenated and given to the pseudorandom number generator. Okay, so that's what happened in WP. But now IV associated with the sequence number. Okay, so now suppose IV, that is vector, and the sequence number is now encrypted by intermediate key. That is intermediate key is known as IK. Okay, so that the seed value is now also encrypted. Okay, and weak RC4 key will not be generated. So generate होने वाला RC4 का keys रहेगा, that will be always a strong key. Okay, now every key sequence will be a stronger one, not any weak key, and that's why key mixing is done. Okay, then the next term is rekeying. Here you get to see next term is rekeying term. Okay, So now rekeying is used again for preventing spoofing. Okay, and or you can say man in the middle attack or impersonation attack. Okay, so rekeying is included to avoid the problem of rollover of sequence number in Michael. Okay, so that means once 2 raised to 24, we know how many numbers can be generated in the case of WEP. So 2 raised to 24 keys, once they are exhausted, that is IVs are exhausted, then you will use the same IV again and again. So this means the same sequence number may be used also again and again. Okay. In the case of WEP. So how to avoid that? So new temporary keys must be generated before the sequence rolls over. Okay. If we get exhausted of all the available sequence number, we should generate the new temporal keys. That is nothing but the rekeying algorithm is involved. Okay. So now this is accomplished by allowing the access point and a station exchange key generation information. Okay. So when we are about to get exhausted of available keys, station and the access point exchange by the or exchange key generation information, and this key generation information is protected by the key encryption algorithm. Okay, so this communication which was absent in the case of WEP. So in WEP, how access point and station used to communicate, they were using shared key that was not defined, a same shared key they were using. So access point and station exchange the shared key. How they are sharing it, that was not defined there. So it could have been easily attacked by the attacker. So now these shared keys are encrypted by the encryption keys. Okay. So in total, what we have what we have till now, the intermediate keys we have with us, we have key encryption key. That's what we have seen till now. The temporary keys is also required, that we have seen encryption key. These are the three different keys that we are using or we have seen till now. Okay, and the further part is so that the KEK keys. Okay, that is KEK is nothing but the key encryption key. Okay, so that KEK keys are pushed into the access point and wireless station by authentication server. Okay, so who are distributing the key? A authentication server. इसका काम है authentication server का काम है. Okay, so that was absent in the case of WEP. Okay, the authentication server and EP, that is access point, being on wired network already, have relation or trust relation. So authentication server is connected to APs and this is through a wired connection. Okay, so they trust each other. Shared key to maintain trust. Okay, a key is needed to a complete or a key is needed to complement the similar level of trust. Okay, that is to maintain the trust. The keys exchange between authentication server and AP, and this is called as a master key. Okay, so master key has to be shared between authentication server and access point. Okay, also this master key is shared with the station to maintain the trust between authentication. Now key that is the station between. Okay, okay, to AS required, we required master key. Then we required key encryption. Okay, that will be required for access point to authentication server. Okay, so let's see the encapsulation process of TKIP, and you will see here how all these keys are used at different levels of encapsulation process. Okay, the above four functions and algorithm resulting in a data, that is here we go to see the big slide for the, so MIS is added to the MSDU, that is MIS is added to the MSDU. MSDU is entire data which will be fragmented later. Okay, so because data might be large one, okay, so MSC is added to the entire data, not individual fragment of data. Okay, so following, which will be following with the fragmentation function, which is invoked. Okay, so each fragment does get its own sequence number. So MSDU is a summation of MPDUs. Okay, now MPDUs are nothing but the fragments of total data. So MSDU stands for Message Service Data Unit, and MPDU is Message Packet Data Unit. Okay, so packets are fragments of a data unit. Okay, so MPDU is a part of MSDU. MSDU is a whole data whole data, whereas per packet, okay, or a single packet. Okay, the result of phase 2 mixing in the per packet key represented as WEP IB, WEP IV. Okay, that is initialization vector. That is along with the initialization vector and the base key. Okay, so we will see the diagram that will more explanatory and will give you a complete understanding of what we have just discussed. For that we require a diagram. Okay, so this diagram is important. What we have just now discussed, that is about this diagram only. Okay, the rest is encrypted following the original WEP, that does not encrypting data as well as integrating vectors. So now here you can see the ICV, okay, and MIC. Now we'll see the first phase, what happens in key mixing phase 1. Okay, then we will see the phase number 2 of key mixing. Okay, a temporal key, okay, for a session and a transmit address PA, okay, given to the key mixing. Okay, so it generates a key, and that is called as a TTA key. Okay, that is called as a TTA key, that is temporal transmit address and key. Now this will be refreshed, okay, every time there is a change of a session, then this key will be refreshed, or every time there is a change of a packet, that we have yesterday seen the duration of changing of this key. Okay, now this key is given to the second phase. Okay, what is second phase is doing now? Okay, so key mixing is second phase is doing. This is covered all type of replay attack. Okay, or man in the middle attack, what we can say, the phishing attack. Okay, so before going to the second phase of mixing, let's see what happened at the other end. Other end means the below end. Okay, at the other end of the transmitter, whatever that is added with the and definition is, and this is as total service data unit. This will be considered as the total service data unit. Okay, so total data is consisting of plain text plus source and the destination address, as well as the priority also added to this MIC key. Okay, that MIC key is, that is nothing but the hashing key. Okay, or hashing algorithm is added to it. Okay, so the total data is now added with the integrity check. Okay, the total data is added with the integrity check. Okay, so plaintext MSDU plus MSC is now divided into plaintext MSDU, that is nothing but the fragment. So it becomes MPDU. It becomes MPDU now. Okay. That is nothing but the MPDU. It is not MSDU. It is MPDU. Okay, that is a fragment. Now for each fragment, a sequence number is located. Every fragment will have the sequence number. Okay, this is to avoid a replay attack. Now each packet with a different sequence number is given to the TTAK key. Okay, it is given to the TTAK key. That happens in the phase 2 key mixing. That is happening to the phase 2 key mixing. Okay, so fresh keys plus sequence number. Now that is to avoid most of the attack that are observed in the wireless LAN, and such number of keys that is temporally and sequence number and actual data is given for the encapsulation process. Okay, so what happens here now? WP seed, that is used for pseudo random number generator. So that is for the key sequence generation of a key sequence is obtained from this one. Okay, so seed is obtained for generating key sequence number. Okay, so now it is XORed with the plain text MPDU, just like in the WEP. Okay, now this text MPDU nothing but the fragment of actual data. Okay, now fragments and actual data are having the integrity check value also. Okay, so key sequence number plus plain text, that will be given you the ciphertext MPDU. Okay, so this is nothing but a ciphertext MPDU. Now importantly, there is a change in the key sequence number. A key sequence number is generated on the basis of two-level key mixing. In the first level, fresh keys for keeping initialization vector fresh we are using, and in the second phase, sequence number we are generating to avoid the replay attack. Okay, and that is used for PRNG. Okay, PRNG is what? Pseudo random number generator. Okay, that is pseudo random number generator to generate a sequence number that is a key sequence. Okay, and that is XORed with the plain text to generate a ciphertext. Okay, now exactly reverse procedure will be followed or will happen at the time of decapsulation or decryption. Okay, and original plain text will be removed. Okay, the second component. Now this is regarding the encryption. We have seen how the encapsulation is done. So now let's see how the authentication happens. Okay, the second component of 802.11 is, or of WPA, is the 802.11x based authentication. Okay, so now this takes care of the weak authentication in original WEP. Okay, because WEP was a one way. Okay, in WEP authentication was one way. So access point used to authenticate the user, but user does not know the access point is user or fake. Okay, because the communication is happening in one direction. Okay, so two-way authentication is 2.1x based authentication method. So what are the modifications? WPA provides two choices of authentication. One is the server-based authentication, that is done is using the radius protocol, that is remote access dialing service. Okay, what is radius is, that means authentication server is just, we have discussed, we will distribute different keys like a master key, key encryption key, that we have discussed. Now that play an important role in the authentication, whereas intermediate key, temporal key, sequence number, these are a encryption. Okay, so remember this thing. So master key, key encryption key, that is for authentication, and other keys are for encryption. The second type of authentication is password based. Okay, which is home network. Okay, which is also called as a pre-shared key authentication, because in the home network you don't need a higher level of security, but in commercial network or in the enterprise networks, you will require a higher level of security. Okay, so let's first see what is the radius based authentication. So radius, when we are talking about the radius, it is stand for remote access dial-in user service based authentication. Okay, so in this infrastructure, a trusted relationship exists between the access point, that is AS, and the server. So AP and the server, AS. This radius server is nothing but your authentication server. Okay, the server and the station use the master key to have the authentication relation. So using this master key, authentication can be done. Once the station has been authenticated TKIP, distributes key encryption keys to be temporal keys at the station and the access point. Okay, so whatever temporal keys you that are used in the case of encryption, so those are get refreshed. Okay, how they are regenerated or refreshed? So that information is exchanged by key exchange information, and that is protected by the KEK, that is key encrypted keys. Okay, so that is the meaning, and this came, or this key encrypted keys are shared by the access point, which are authorized by the authentication server. Okay, so there is a multi-level security provided. In this case, mechanism is applicable to only enterprise network, which can afford to have a separate server key distribution. That is authentication. Okay, so the job of that server is to distribute the keys. Okay, so key encryption keys are used for encryption information, which is shared with the station by the access point in order to regenerate the temporal keys. Okay, so to regenerate the temporal keys, an information must be coming from access point, and that information should be encrypted, and encrypted by the, so these keys, key encryption keys, are distributed by authentication server all the access point. Okay, so this is very important. And second type of authentic pre-shared key authentication. So it is for whom, small business, or where it does not require any kind of server. So access point and station are configured with the secure password, so that is used to generate the key. Okay. So again, temporal keys will be refreshed and regenerated. Now responsibility lies with the access point. Okay, information exchange is encrypted by the key encryption keys, but these are generated by the access point. Okay, the information exchange is encrypted by the key encryption keys, but these are generated by the access point. No authentication server. The authentication is performed using a PSA. Okay, the key is derived from the user credentials that have been entered in the AP. Okay, so key encryption key is derived from the credential that have been entered in the access point. Okay, so this is regarding the WPA. Okay, now let's briefly look into the threats that we have, or that we see in the wireless LAN several times. So we have seen WEP previously. So we have seen the flaws of WEP. and in the WPA we are trying to overcome those flaws. Okay, so we have seen several types of attacks that can be encountered. So which of those attacks can be seen in the wireless LAN, and which are other attacks that can be seen in the wireless LAN, and how many of them can be avoided by the WPA? Okay, so first is the accidental association. First is what? Accidental association. So that means if two networks overlap with each other, that can happen in the case of wireless network. So sometimes if they are not using any security like WEP or WPA, one user may get connected to the other network, okay, unintentionally. So if it is the open system authentication, so that can happen. अगर वो open network रहेगा तो that can happen. So this can be easily avoided by WEP or WPA. So both WEP and WPA, okay, are able to avoid this kind of unintentional attacks. Okay, then the second one is malicious association. Second one is malicious association. Sometimes malicious access points, specifically in the free public Wi-Fi, can steal passwords. So let's say a rogue AP or a fake access point provides a service in the network. Okay, so if you connect to that particular network, it may happen that it can steal your password. Okay, now that can be avoided by the WPA, okay, and WEP also, because now some sort of security will be provided in WEP as well as WPA is secure. Okay, so first two are the pretty basic attacks that can be easily avoided. Then the third one is avoiding eavesdropping. Okay, so non-traditional networks like a Bluetooth, so using Bluetooth you can drop Wi-Fi communication. Okay, now how that is possible? So if you remember, so WLAN uses a 2.4 gigahertz ISM band. 2.4 gigahertz ISM band is given for operation of Bluetooth. So Bluetooth also falls in this category, and Wi-Fi is also falling in this category. So if both are using the same frequency band, so it is easier to eavesdrop using a Bluetooth. Okay, because radio frequency is same or band is same. Now that can be also avoided using a WPA. So next one is a MAC spoofing. So now spoofing means imitating someone else's identity. Okay, so copying someone else's MAC address, okay, or changing it to match the privilege computer. So that can be done, but this will be done in order to listen and possibly to modify the computer. Okay, so that is also by the WPA. Okay, MAC spoofing will work only once. The next time the temporal key are changed, computer station will not be able to communicate then. Okay, so then the next attack is that is nothing but the man in the middle attack, where some fake access point or fake station which appears to be service a request for communication, and okay, that can be encoded. So, and it is not only the station, so that is called as a rogue IP. Okay, using rogue access point between the user and the actual access point can be hijacked by WPA. DOS attack, that is denial of service, as well as that is distributed denial of service attack. So that is keeping the media busy. You take repetitive packets, so that can be avoided using WPA. OS and DDoS is attacks are not entirely avoided, but ripple attack can possibly solved. Okay, then network injection. Okay, that spoofing the actual sequence of or actual sequence number using the sequence number to deliver to the destination. Okay, this can be did by using W. And the last one, that is evil twin attack. So that is nothing but the rogue IP. That is nothing but the rogue IP. So fraud access point are created, and by mistakenly you get connected to it and your data can be stolen. Okay, so that can be again avoided with the help of WPA. It's related to wireless and be solved with the help of WPA, or can be avoided with the help of WPA. So that is what security related information related to 802.11 or Wi-Fi or wireless LAN standard. Okay, so we have two different protocols. One is WEP protocol and the other one is WAP protocol. Okay, so that is what the security is. Okay, apart from that, 802.11 has several different standards. We have seen 802.11 8 standard as well as 11B standard, but it is also having standard named as standard C, standard B, and standard H. So it has basically standard B, A, C, D, and H. So task groups are working on a special regulatory and networking issues of those standard. So IEEE उसके अलावा एक standard है, that is IEEE 802.11e standard, that deals with the requirement of time sensitive applications such as voice and video. And IEEE 802.11f is one more standard that deals with the inter access point communication to handle the roaming. Okay, और एक G standard है IEEE 802.11g that aims at providing the high speed of IEEE 802.11a in the ISM band. Okay, so IEEE इसके अलावा और एक है IEEE 11i जिसके बारे में हमने सुना है already. Okay, so that deals with the advanced encryption standard, that is AES standard, to support the better privacy. Okay, so these are the standard. What standard we have seen? We learned only two standard, the 802.11 B standard and the A standard. But still, apart from that, C standard is there, D standard is there, H standard is there, I standard is there. Okay, F standard is there, G standard is there. So there are certain different standards that they have developed. Okay, so उसके बाद में one more standard is, that is hyperLAN standard. Okay, so apart from 802.11 standard, there is one standard known as hyperLAN, which is a short form of high performance radio LAN. And this standard is defined by the European Telecommunication Standard Institute, that is ETSI. Okay, so it is to be noted that while the IEEE 802.11 standards can use either a radio access or a infrared access, the hyperLAN standard are based on the radio access only. It is not available in the infrared access. Okay, the standard have been defined as a part of the ETSI broadband radio access network. Okay, that is BRAN network, BRAN. Okay, under BRAN project it is developed. In general, broadband systems are those in which user data rates are greater than 2 Mbps or can goes up to 100 Mbps. So इसके नीचे 4 standards have been defined for wireless network by the ETSI. उसमें दो standard हमें पढ़ने के लिए है. The first one is the HyperLAN 1 standard, is a wireless radio LAN, RLAN जिसको बोलते हैं, without a wired infrastructure based on the one-to-one or one-to-many broadcast. So it can be used as an extension to the wired infrastructure, thus making it suited to both ad hoc infrastructure-based network. Okay, so it employs 5.15 gigahertz and 17.1 gigahertz frequency band and provides the maximum data rate up to 23.5 Mbps. दूसरा जो है that is Hyperland 2 standard that intend to provide the short range wireless access to the internet protocol and asynchronous transfer mode and other infrastructure based networks, and more importantly to integrate the wireless LAN into a cellular system. Okay, so it employs the 5 gigahertz frequency band and offers a wide range of data rates from 16 Mbps to 54 Mbps. Okay, so Hyperland 2 has been designed to meet the requirements of the future wireless multimedia services. So these two standards we have for study. So in the next lecture we will study that. Okay, apart from that there are two more standard. One is the hyper access standard. Okay, that is originally known as Hyperland 3, that covers the last mile to the customer service. Okay, so it enables establishment of outdoor high-speed radio access network that are providing fixed radio network connections to the customer premises. So hyper access provides a data rate of 25 Mbps. So it can be used to connect the Hyperland to deployments that are located far apart, suppose up to 5 kilometers. It offers point to multi-point connection communication. Okay, then next one is four category is the hyperlink. Okay, that is Hyperland 4 basically. That standard, this particular hyperlink standard provides the high-speed radio link for point-to-point static interconnections. So this is used to connect different Hyperland access points or hyper access networks with the high-speed links over the shorter distance up to 150 meter. Okay, for example, the hyperlink can be employed to provide links between different rooms or the floors or within a buildings. Okay, so hyperlink operates on a 17 gigahertz frequency. Okay, so that is what the types of hyperland we will study. We have to study two components of it, or two components. One is the Hyperland 1 and the other one is the Hyperland 2. Okay, so that's what we are going to study in the next lecture. So that's all for today.